What excites you about engineering, and why do you think you'll be a great fit for the academy?
I think I'll be a great fit for the academy because... Wait, you know what? This isn't right. Let me start it again. This is a lot better. Hi guys, my name is Sidhanth Lade and this is my application video for the 2025 Williams Engineering Academy. And I believe engineering is the most powerful tool humans have at their disposal. It's the most powerful tool we have to create meaningful change. Me, for example, I've spent the last few years of my life researching into how things work, from the airflow around a front wing in an F1 in school's car to the hybrid power scales of industrial engineering. And I'm ready to take that learning to the next step. This academy combines two fields I'm exceptionally passionate about: elite motorsport and high-scale engineering for the real world. The fact that I have the chance to contribute to both, solving performance problems while maintaining sustainability and efficiency, is exactly why I want to be here. For me, engineering is not just understanding how the world works, but how we can make it better by answering endless questions. Questions such as, why do F1 cars lose pace in the rain? How do ERS systems manage thermodynamics while maintaining output? How do some aerodynamic structures cause stalls of turbulent flow? All questions that I had to find the answer to. They became intense curiosities, so I started learning. From Adrian Newey's book on how to build a car, all the way to White's dissertation on fluid dynamics, to online lectures about CFD, thermodynamics and mission systems, all of which helping me to understand what's going on. And what I understood was, this is no longer just simulations and equations like what we see in the classroom, but real life examples with real life constraints, and that's what excites me. And not just in the world of F1, companies like Komatsu themselves and what they're doing, pushing innovation in sectors where efficiency, safety and environmental consideration must coexist. For example, the HB365LC-3 isn't just a regular hybrid excavator, it's a case study in applied systems engineering, balancing hydraulic performance, which is battery powered, while reducing fuel consumption, while maintaining productivity in a high load environment. And for me, understanding how these machines are produced, designed, monitored and refined to consistently deliver high performance in complex situations, that's what excites me. That's what I want to do. It's engineering that serves a global purpose. And I just don't want to study engineering. I want to apply it. I want to solve problems. I want to rethink systems, to push the limits of human ingenuity and physical capabilities, to make what one can call a work of art. Because for me, that's what engineering is. It's an art form, and it's an art form that I want to master.
Can you describe a problem which you've encountered recently, where you've had to use teamwork and resilience to tackle it?
Well, yeah, 100%. For me, engineering doesn't happen in isolation. It can't. Some of my most valuable growth moments have come through when working with others, particularly in challenging situations. For example, at the UK Space Design Competition, our team was tasked with designing a sustainable Martian base, considering thermal regulation, structural stress, atmospheric pressure modeling, and even life support systems. It was a deeply interdisciplinary challenge where everything relied on each other. But halfway through, we realized our design was failing. Our centralized designed idea would fail under low gravity. And then the team, they started stressing out. But I, as a structural engineering chief at the time, decided that we should repitch the idea into a spoke hub modular setting. And rather than completely dismissing everyone, we decided to work as a team, find the root cause of the problem, and fix the problem as a whole. This idea was so successful that at the end of the competition, held at Imperial, we won the Judges' Choice Award, showing that innovation, perseverance, and teamwork is all that's needed to be successful. And this mindset also helped us cruise to second place in this year's UK National Finals. For example, as a design engineering team, we hit a roadblock. Our car, no matter what we did, would not get any quicker. Nothing would happen, even after several iteration changes. The team, they were getting frustrated. So again, much like space design, I took initiative to find the root cause of the problem. And the root cause was a wrong concept. So we decided to bring in a new concept, and that worked perfectly. As a team, we collaborated with loads of late nights and loads of CFD files, producing a much better car with a lower drag force, better gradient distribution, and a better wake region, showing how perseverance and teamwork is key in engineering. Additionally, manufacturing this car caused us so many issues. Our school's CNC machine broke midway through manufacturing, so we had to reach to an external company so that they could make our car for free, again showing how collaboration is key in engineering. Beyond competitions as well, I try to cultivate teamwork and collaboration within my school. I've led Physics and Engineering Society for half a year now, creating talks and inviting younger years so that they could understand what it's like to study engineering or hope to study engineering. I've also tried to improve my technical communication by pursuing a grade 8 Lambda course so that my public speaking could be at its best, because again, I really believe that engineering without communication isn't engineering at all.
Tell me about a time where you've pushed your limits and you've been exceptionally proud of your work.
When I think of pushing something to its limits, the first two things that come to my mind are the FW47 and the Komatsu HB365LC-3. Both that seem worlds apart, but to put it simply, they are the product of intense ingenuity, precision, and relentless iteration, pushing performance while having constraints. And that's the mentality I put forward in my own personal projects. One project where I really had to push myself was my mini F1 car build, something that I chose to do out of my pure own interests. I researched motor configurations, comparing torque curves, energy outputs, weight penalties before choosing a setup that offered strong acceleration without destabilizing the chassis, all of which is something I want to do in the future, so I thought I'd give myself a little taste now. I modeled the car in CAD, then ran iterative CFD simulations to find the best aerodynamic output. All of this was incredibly difficult. I had very little understanding of it, but what I had to do is I had to push myself to find out more, to learn more about the situation. And ultimately, each failure that I had further refined my understanding. The benefit, there was no deadline, there was no judges, but just the challenge of chasing that improvement and pushing myself even further. When the car finally ran with a fractionally better aero balance, weight distribution, and performance, is incredibly rewarding, and that's when I was quite proud of my work. Furthermore, working a week at the Department of International Trade provided me with new challenges. I had to create a satellite prototype with severe manufacturing and time constraints. Some constraints I already knew. Rules, regulations, the same old we see in F1 in schools. However, other things like manufacturing costs, fuel costs, how big it should be, how little it should be, new challenges at a much larger scale. And after loads of hours of working and constantly rethinking my designs and researching, I eventually presented a successful satellite prototype, something that I was really proud of. What further added to the challenge, I wasn't presenting to anyone. I had to present to senior industry leaders and government officials, something that added to the challenge but made me really proud when I successfully did it. Eventually teaching me that engineering is not about how much you know, but it's how much you know and how well you can communicate it. And with that, this experience had been incredibly rewarding. And that's what I love about the FW47 and the Komatsu excavator. They're the product of constant refinement, constant solving of challenges, something that I had to discover throughout both my personal projects. And that's what I want to do in the future. I want to find solutions to the challenge. I want to innovate. That's what engineering is to me, and that's what I'm passionate about. And joining the academy wouldn't be just a milestone. It will be the launch pad for me to achieve my goal in the future of becoming an F1 engineer. So with that is my application video, and thank you very much for taking the time to watch it.